A very common type of reaction that takes place in solution is an acid-base reaction. An acid is a chemical that can donate an H+, a proton, to a base, and a base accepts that proton. So for example, HCl is an acid because it can donate an H+ to water. Water is acting as a base. When we add this H+, I draw the arrow in that represents that transfer, and the water turns into the hydronium cation, and the original hydrochloric acid, after it loses an H+, is now the chloride anion. If I switch the acid from hydrochloric acid to acetic acid, the reaction looks very similar. The difference is I write this reaction with arrows that point both ways, because acetic acid is a weak acid. In hydrochloric acid, the arrow is one directional because hydrochloric acid happens to be a strong acid. With the weak acid, the reaction can go forwards and reverse, but you find the products exactly the same way. If I add an H+ to water, it's going to turn into the hydronium cation. And the original acetic acid, after it loses an H+, is going to turn into the acetate anion. Notice the reaction is balanced for atoms, and it's also balanced for charge. The left-hand side, 2 neutral chemicals. The right-hand side, 1 cation, 1 anion. So the charge is conserved just like the mass is conserved. Acetic acid is often written CH3COOH. This is a very common pattern, chemicals that end in COOH. So when you see a COOH, you should recognize that that is an acid, and it's that proton that can get donated to water. So we can write that as hydronium, and then acetate can also be written CH3COO with a -1 charge. Chemicals that contain nitrogen with the lone pair are typically bases. So NH3, instead of donating a proton to water, accepts a proton from the water. That makes water, in this case, the acid, and ammonia is the base. This is also a weak chemical, so we're going to write this with double arrows. The products are a little bit different. When you add an H+ to NH3, it turns into the ammonium cation. And what's left behind on the water after we rip off an H+ is the hydroxide anion. So whether you're talking about an acid or a base, if the chemical is strong, that means it's going to react completely. And here are the 6 common strong acids. Strong bases also react completely. Strong bases are group 1 or group 2 cations paired up with OH-. So things like potassium hydroxide, sodium hydroxide, those would be strong bases.